Hey Raj, how you doing, man? Not too shabby. Not fasting today.
Oh, you're not fasting today?
No. What about you?
Is your day off? Oh, because you're at a different party, right?
Oh no, no, not at all. I just didn't get to do it today. So I'm drinking a lot of coffee. Yeah, I'll see you.
Yeah. So, actually, not too worried because it's just a space. So there are strings, strip. The string is not strip. So you need to do that in a series, right? So you need to. So you remember apply. So DF reading. So this is the series with all the readings. Okay? You dot applies, right? You apply some function to it. The function you want to apply is the function. So what it's going to do is it's going to apply this function to each of those strings. Problem is that the function you're looking to do is a method. The string you can't directly apply. So what you're going to have to do is call a long. So usually when you define a function, right, you do like f apply. You write it on there. And you can do that here. Actually, you guys should have this. It's not as string, whatever you're. So what you're going to do is you're going to create a little function in line and wave through that through simple right lambda x and then colon x dot string. So what this is this is the equivalent of doing S. So you can do this. We put this envelope here, and then put strip string in here. We put it without parentheses. That requires a lot. And in these kinds of situations, it's nice to do long. So that creates a function that goes in here, and it's so you put lambda here to let it know that it's lambda. And then you put the arguments in the function. And then you put the body in the function. So actually, so this is equivalent to this thing. Equivalent. Anyway, so what that'll do, so that'll do here is create a new series. So you either replace the old series with a new one. So all I do is equals. Right? So this says, okay, I'm going to take rating, I'm going to apply this lambda function to it, and I'm going to get a new series, and I'm going to replace this series with a new one. Yeah, this is this. That is assuming that you don't care about the fact that you're losing the ones that have the function. Right? If all you care about is doing it and making it better, you could call this, you could like have this be rating fixed, rating 2. Right? And then this will still be there. And you'll just use rating 2 for that. ready to go. But if you don't use that much for 2, it'll replace it. So strip, what's the word?
Yeah.
Yeah,
But so they're all strip.
Yes, so strip will remove the left and right sides. No strip or strip, and there's just strip. It removes not just spaces, it removes everything. Space. So it'll also remove like a new line. So if you can slash it in, it'll remove that. It may have optional arguments, you may be able to specify what you want to strip on. I've never used that. I wouldn't be surprised if you could.
So that's the part. Especially needed.
It has to be whatever the data frame is called. So a prop. So I just heard you. Let me replace that. So, and actually, there's probably a pandas function you can call that does the strip. I don't know offhand, so this is it's probably not any faster.
Is it the X, the actual code?
X, so X represents the thing in the it's whatever variable. It's what's replacing it, it's representing is what's in that cell. So why did you? Is there a reason why you use this sort of set instead of me? Oh. So you could just use. I don't know. It shouldn't. It shouldn't. Because it's still considered. Unless I understand, it actually does not. I highly doubt it. But it's just instead of having to do this sort of set, you can just do. Yeah, that's right.
Hey, how are you?
Yes. Okay. Yes.
This is
I have a.
second to last.
Sorry?
This Tuesday, next Tuesday. Oh, no, we have 3 more.
Pretty good. Yeah.
This 4. Yes. And then we'll go over. I did not use those. I tried, but it didn't use them. But the things that I was reading constant, like, started that one web to use one. And something else, though.
So you do like 5 content rating equals R. And that's what we asked you to do.
I'd say ratio too. What should I do? Yeah, I just did this. I didn't know if it was that.
So
It's the same.
we have in here, if we have series, constant,
That's like the opposite.
and we have five, and say, well, now,
That's a big time.
and then that equals new series of units.
That's actually really kind of
So
exciting.
brackets imply a prod, and it filters those prods on where the
It took me a while, but none of it.
Yeah, when I did it, I had.
Yeah, so it's like really messy. A lot.
But I had to make.
It's weird, now that I'm not a student, I really enjoy it.
You can, you don't have to. And then what you want to do is there's an extra. So now, and then you want to do, now you have, this is data, right? So now you can do sort. And now you sort by,
No, I don't think that it
also, yeah, also it's ascending.
the same
So this will be
in
modified.
I did it.
So you can do ascending
Oh, no, I didn't.
all plus.
Yeah.
Yeah, because you want it to be descending. You want to start at the top and then descend. And then,
Yeah, that's all it says.
no, because it's either ascending or descending, so it doesn't have the descending part, because instead it has the descending. It's by default descending.
That's it. That's
Remember, don't think of it as a word, think of it as a bunch of paragraphs. Then now you spell out the English word descending. So the computer doesn't understand descending or the opposite. And then remember, you want the
Yeah.
that's a lot of text, all in one line.
Yeah, so
So what you can do is like
like I made that.
you can cut it off here, right? R, and then you mark it off. I honestly, I can't just hear it.
Isn't the
Sorry?
she's really conflicted and she chose to sit there.
But no, it's
part of our no, what the hell? It's fine.
Sorry.
Because it's not. You just don't, you use the word ascending.
It's so if I were to be.
Ascending will automatically be true. The default value for ascending is true. So you have to tell, sorry, for ascending, yeah. So you have to tell it to be false. books?
So I'm ordering the class. I spoke to Neil Newland,
Okay.
sales. I spoke to Top upstairs.
Okay.
And one thing we did saw is the immersive concept course of the months. So they said I get a flavor of the course. So it's on this one today.
Okay. Just wanted to make sure.
Yeah, this didn't get lost. Yeah, thank you. I get lost. I ended up upstairs, and Pat's calling us to come down here. So.
Yeah, well, yeah, he would normally be teaching this class. He's there for like 15 minutes because there's a new class there. But this isn't the first day of this class.
Yeah, it's okay.
Okay, yeah, it's okay. If Cox told you. Sorry? For a little while, because talk is going to be late. Because, well, yeah, I was about to explain. So, for those of you who hadn't heard, talk is going to be teaching another Python class, and so he is going to be at that class for about like 15 minutes today. So I'm going to be starting the lesson, and we'll be starting in like a minute. Yeah, so I'm teaching.
Is that the structure of like, or like, that in here eventually to start teaching as well? Like,
No, because they don't need it. Like, no, that's not the plan. Like, it just happens to be today the talk needed me to cover the first 15 minutes. He's going to be here a little late. All right. Looks like most people are here. All right. So today we're going to be starting talking about data visualization. So we're going to talk about why it's important for communicating results. I'm just reading out. So basically, we're going to talk about data visualization. So we're going to look about how do we make sense of a data set, right? So when we look at a data set, we often can't look at the whole thing at once because a lot of times it's going to be too big to look at. So we need to find some way to compress it down or something, but this kind of format just isn't going to work most of the time. It's a good way to get an idea of the structure of it, not the actual makeup of it. So we use data visualization. It's a quick, easy way to convey concepts from large data sets. So, what are the good criteria for a good visualization? It needs to be simplified. You want to be able to look at it, it's not be overwhelmed. It's going to be easy to interpret. You want it actually to communicate information. It needs to be clearly labeled. You don't want to have your X and Y axis or whatever be unlabeled because then you don't know what you're looking at. And as a bonus, it's nice if it's interactive. It's something you can maybe change a slider and something will change. So, how do you choose the right chart type? You have a lot of different kinds. Pie, bar, column, line, area, off. So, you think about what are you trying to show, right? So, words, categories, numbers, how much data there are. Maybe you're trying to sort of tell a story. So let's look at the first one. When to use a bar chart. So they're useful for illustrating like a string or one numeric variable. So it's good when you just want to say, I have a couple things, and I want to say which one's the biggest or which one's the smallest. And I don't have a lot of variables that I'm looking at. It's really just kind of one variable. There's options, you can use vertical bars, you can use horizontal bars. Are you going to always have your axis start at 0 or maybe somewhere else? And does the order of the bars matter? Do you want them to be in descending order, ascending order? Do you want them to be sorted by something else, maybe alphabetical? So there's options with bar charts. Here's the pie chart. So the big thing with pie chart that's nice is that they're really good for percentages. Because you have this notion of there's only limited space that everything can fit in, so it's telling you how much of a percentage everything takes up. So it's really nice for that kind of purpose. They're often misused because the thing about showing people percentages is that it sort of skews the notion of actual quantity. For example, if I show you a pie chart of, I can't think of a good example because I didn't prepare one. But the idea is that if the pie chart tells you percentage of the entire US population that has something, and it's a small sliver of that pie chart, if it's the entire population of the US, it could still be a really big number. And it could be a little deceiving. It's like, oh, it's only a small percentage of the US, but that could still be 1 million people, and that's a lot. So you want to be careful with the notion of showing percentages because it can be a little misleading when percentage maybe isn't even really the thing that matters. Oh yeah, and also there's the issue of just, there's just the issue of like, it's not very precise when you look at it. It'll give you the number, but like, you can't really tell just how big each of those pie slices is. You can kind of guess at it, and obviously you can read the number, but it's sort of approximate. So using bars could be better for that kind of thing. So here's scatter plots. So the big thing about a scatter plot is it uses 2 dimensions, right? It uses 2 dimensions and its points. So unlike something with a bar chart, where you have each bar has a height and that's it, here you have, it has an X point and a Y point, and you can sort of start to see correlations. So here, girls' least in science exam, but not in the US. So here we have the x-axis is I don't even know what this is saying. And I think that's the point they're trying to make here. I should have prepared more for this. So, when do you use a scatter plot? Sorry? Yeah. So, when do you use a scatter plot, right? So, it's not as common, so it can be harder to read. So the dots can kind of crowd and curve each other up. So that can be an issue. One variation is the bubble chart, where you sort of show, it's sort of combine points together into bubbles, and then the size of the bubble tells you how much clustering there is in that area. But they do give you a good sense of like trends. It's an easy way to see correlations. If all your dots kind of fit in a straight line, there's definitely a correlation there. So that's something that you get from scatter plots. So here's a question. Annual sales in each state for a grocery store chain. What kind of chart should you use? Okay, so why?
Well, because I find scatter plots really good when you have a y variable. This doesn't really have an infinite variable. This is not part of a whole, so it doesn't make sense to use a pie chart. And like for visualization purposes, it'd be nice to see them all.
All right, yeah, that makes sense. Does everybody else agree or disagree?
I use a scatter plot because if we're turning every state into their long bars, and then they, like, depending on how you create the bar chart, maybe too many bars for comparison.
Okay, so in that case, then what would you have the axes be? So one axis would definitely be sales.
Oh, yeah, actually.
Right. So that's a good point that you bring up, though, that maybe there's too many bars. That's something that you would, you mess around with how thick the bars are. And that's where the previous thing comes into play of what order do you put them in. It might be a situation where you want to put the bars in order of from greatest to least, so that even if you're not seeing the individual states super well, you're at least seeing the distribution. So that's definitely something to consider. Yeah. So histograms. That actually kind of goes in nicely to what I was actually just saying, which is, so a histogram tells you the distribution of something. So it tells you for each sort of amount, how many things have that amount. So here we have sales. So here we have number of sales. Okay, yeah. So this appears to be, we have, here we have the price. This is a little hard to tell exactly what it's
Housing sales.
It's housing, it is housing, that's what I thought. Right, so we have our x-axis is the range of house price, right? So here we have 0 to 50, and here we have 550K to 600K. And it's telling us for each range of price, how many of those houses or real estate type objects were sold over time. So this tells you, it gives you an idea of sort of a distribution. So yeah, it gives you an idea of a distribution. So they're not the same as a bar chart. The important thing is to note that in a bar chart, you have, we said before with the states, each state has a different number. In this case, what we're looking at more is how many times does something appear in a given category. And you can change the sort of resolution of the bar charts with the amount of bins.
Oh.
Yeah, buckets. So that'll tell you, it'll sort of, you can bring it down to like $1 increments, right? And you have this chart that stretches out and has all these little things on it. It wouldn't be very useful. So actually that's an important part of histograms, is taking how many bins, or rather how big the bins are. And it'll change sort of how good the resolution of the bar chart is. And there's a whole science to that by itself. So here's the main difference between a bar chart and a histogram. We have here, this one is distribution of variables, whereas it's to compare variables. So you can see here, this one, the x-axis is different countries. The other one, the x-axis, is different amounts of things, or different measurements, whatever they may be. And usually bar charts have gaps between them because the goal is to separate them, whereas with a histogram, we sort of want to show a progression and that there's sort of a connection between all. So, what if we want to talk about the relationship of average income to education level? What kind of chart would we want to use?
Scatter plot.
Okay, why?
Because you want to see if there's a correlation between the two.
All right. So now scatter plot has 2 dimensions to it. So how would you
Do an average income on one axis,
Okay.
education level on the other axis.
All right. Makes sense. Does everybody else agree, disagree? Yeah. All right. Cool. Great.
Let's examine whether you're somewhat continuous variables rather than discrete.
So
Education level depending, it could be in like years or.
yeah, I think we're assuming in this place, because it doesn't really give us much detail, we're assuming that education level is a number. That is a good point. It could be that we say graduated high school, graduated college, something like that, and those could be sort of separate enough that we'd want to use a bar chart. That's definitely a possibility.
I think it's more illustrative if you have a bar chart. Actually, you want to see what's college education, what's high school education, so.
Yeah, and it depends on what education level even means in this case.
It's scatter plot is when it's 2 dimensions, and the question is that education level, is that considered like another data point? Or is that more like a bucket for the state?
So the point here, by the way, that we're getting on is that there's room for interpretation, I think is the big thing. You have some options, and it can depend on specifics. So yeah, so we look at a line chart in action here. This is an excellent way to show change over time. So here's the idea. Here is, as opposed to a bar chart, a line graph is continuous. So there are not discrete single things that are separate. They flows into each other. So this is definitely better for when you want to show a variable that changes more quickly. So in the case of bar charts, you have separate categories. In this case, you have an easy example is time, right? It's just actually, yes. It's continuous because time is continuous, depending on how deep you want to go into the physics. But it can be represented as a continuous variable. So when you want to use a line chart, like I said, it's when you have a continuous variable as opposed to a discrete variable. And a continuous variable may be discrete, but may be virtually continuous, at least for the purpose of displaying. Time, again, is just the easiest one to mention. I can't think of any other off the top of my head, but there's definitely other variables that you want to represent as a continuous variable. So you're gonna potentially want multiple lines, in which case you're gonna want to have different colors for them, and the individual data points are going to be harder to read in this case because they're continuous. But it lets you see trends, which is maybe more important for the data you're visualizing. So
Usually have legends, right?
yes, usually they have legends, and oh yeah, there it is. Yeah, you want a legend. Obviously, you want to be able to label charts. We talked about that at the beginning. It's an important aspect. So which type of chart? Change in average income since 1960 for American adults.
So one of this question, or like all these questions, you should never use a pie chart.
Well, yeah, kind of, yeah.
Pie chart's been on every one, and it's never been the right answer.
Yeah, I mean, if you think about it, pie charts show up the most as a meme. Like, have you seen those? Anyway.
Pie charts are personally, I want to use a pie chart for everything. Because all my data is misleading. Yeah, great.
So,
Line chart.
line chart for this one? All right. You want to justify it, or does it seem kind of obvious?
Time on the XMC.
All right.
It's just explain what the line chart is.
Yeah, it's a little bit of a gimme here. Yeah, definitely, and that's the difference between line and bar is the fact that it's continuous versus discrete. So the bucketing turns a continuous variable into a discrete one. So yeah.
Just as a side too, like right here, the scatter plot so far we know is the only one that there's two variables
Yes.
together. But a lot of times bar charts get combined with line charts as well.
Yes.
Right? So you compare two different sets of time series data.
Which is sort of like what Alyssa was talking about. You could do what you suggested with the bar chart and also overlay a line on that to show both of them. Yeah, definitely. And that also happens with histograms because the histograms are often discrete, at least in terms of empirical histograms. So you end up seeing a line added to it because it helps show how it's distributed according to, like if it's a normal distribution, something like that. So knowing how to choose the right chart. So here's a series of charts.
Keep going.
Yeah, keep going. All right, let's open this one up. Whoa. So, look at this. That is me. All right, there we go. So let's take a second to absorb this one. So what does this say? And I think, right, so these are each the same data. Yeah, okay, that's it. So we have here a bar chart. Top US films in each decade, or each every 5 years, or every year, it's just that. So I'm not really sure how to even read this, honestly. And I think that's sort of, yeah.
I like to call these moving pie charts.
Okay.
Right? Because I mean, it's like, first of all, the y-axis is set, right?
Right.
It's half a bit, right?
Yeah.
So basically, what this tells you is sort of like, again, the distribution, like, of domestic box office as the
I'm
years
seeing it
go
now.
by, right? And as you can see, for example, the spike in, spike in orange just clearly tells that, there's an increase in, like, movies that gross, that come from true sequels, right? As as adaptations become lower. So it's, again, a great way to just see sort of like the trending of distributions of, like, again, different.
Yeah, lots of originals over the late 70s, 80s.
They remake 10 films.
Oh, they used to remake a lot more films than people realize. Like Wizard of Oz has been remade a lot of times, a lot of old versions of it. And the one that everybody knows is actually a remake of like an older version. They started making it before that.
It's like the 20s, like, they're silent films.
Also, it's a way to make film actually the series of pictures.
Well, you'll learn how to do that when we cover Matplotlib. If you want to make one, you can make one in a grid or whatever, and it's going to be completely illegible. You'll love it. So here we have, actually, this is very similar.
This was more when I was.
Yeah. So this is the previous ones, but it's been sort of smoothed out by using a rolling average. So what it does is it takes for each year it looks at the 5 years surrounding it. It takes the average. So the data is a little more regular, but it's a little less accurate, precise. I can never remember. Anyway, it's a little easier to read, and it shows the trends better because it's less jagged, if you will.
So that's the only difference.
That's the only difference in this case. It's just that it's using a rolling average. But yeah, and it just doing the rolling average does really do it a lot for the legibility. So here we have the same thing, except instead of, or sorry, it's not the same thing rather. It's a rolling average again, so it's smoother. But instead of showing us the percentage, it just shows us how many in each separate line. So this here we see, lines go below other ones because they're not. It's not the sum of all of them. They're not stacked. They're just all being put in overlapping. So what this version shows us instead is it shows us how different types of movies sort of compete with one another, as opposed to just showing what makeup they make of the total. So, and then here we have yearly average by decade. So this shows us, this is a lot like a pie chart in the sense that it shows us for each decade, for each type of film, what percentage it makes up of the top. And in this case, it sort of does a similar thing to what this one is doing, except it's doing it in a way that's separated. And what that does is it sort of shows things on their own. So we see that, like in the previous version, True Story is, you can tell that it's the same thickness throughout, but it appears as though it's descending when it's really not. It's actually pretty constant. So it's an important difference. And it's showing us here that sequels have become more and more popular. Remakes have actually paradoxically become less popular, even though some people would think that they have become more popular. Although we can see that they kind of went down and they came back up. And it shows us that adaptations have gone down, whereas in the previous one, adaptations do look the same. And original movies also, it does give a different visualization of the data. So,
What's that called?
So the big thing here is that these aren't like one single type of chart. This is, I guess you'd call this a,
So it's a box.
would you have a name for this? Nah.
I don't.
Yeah. It doesn't exactly, yeah, it's
Multiple bar charts put together.
yeah. Yeah, it's not, it doesn't like fit into the, doesn't fit very well into the categories that we went over before.
Actually, it's called stacked bar charts.
Yeah.
Which is like similar to this.
And that's really more like what this was. Yeah, this is more like, this is a stack bar chart.
It's almost like an area chart. Huh?
Yeah. Well, the thing with this is it's a stack bar chart in which the sum is always the same.
Because
So a stack bar chart doesn't have to.
original Instagram, you had the house sales, that's like a stacked bar chart.
This one. Yeah, this one was a stack bar chart. And the thing with this one is that, well, it's a histogram, it's a stacked histogram.
Stacked.
With this one, the heights are all different. With this other one, the overall sum height is the same because that's what was chosen for the data. But it's still a stacked bar chart. It's just one in which they all add up to the same thing.
Almost like a heat map.
Yeah, I guess you could say that. Kinda. The heat map usually is when you have a scatter and you have a third dimension that you want to show. So each pixel is colored from sort of cold to hot based on that third dimensional value. So it's a way of doing 3 dimensions flat using color. I don't think we have an example of that. But there's a lot more that you can do, obviously, with visualizations. What we covered was the basic stuff, and then when we looked at this other page here, this shows us sort of all the minutia you can mess with. So, oh yeah, so we're going to do a group activity. So we're going to get in small groups, 2 to 3. We're going to go to this website, Data is Beautiful, the Reddit subreddit, and you're going to pick one that you like and one that you don't like, and try to figure out why you do or don't like it. So, yeah, so we're going to do that.
Sorry? So I owe you 2. Thank you. Oh wow. Thank you. Especially since yeah, I'm just gonna have
Yeah, that's the one I
I love the.
You know, my problem with this site is I don't get a lot. I gotta like really crack my brain. So yeah.
People didn't like the last year. I feel like I've been No, yeah. Where, for example, so you go to the whole night, there's a lot of different articles for you to be able to look from, right? And when there's too much, so like those but mine isn't. That's like, it's just. Right, for example, like, Amazon /part, right? Amazon if your house, when they go to the same place, but better makes it differently, it's on this. I'm sorry, that's the I work with T-Mobile on data.
I think this one is.
I haven't seen the last.
We also don't
This one is. I mean, okay, there's something. Exactly.
Oh, I did.
So, yeah, you mix it now. You know, I think that because I don't use it, we're now we got 2.7. And then the average is something else. Yeah.
So, scroll up.
Yeah, oh, yeah.
Oh, I'm sorry, like, that ruins the entire show.
Game of Thrones or.
Yeah,
It all makes sense.
I need these 5 hour like
The story about all I was way more. That's just like it's important and Robin's marriage that I was. There's so many. She died okay. Whatever. One of Barney Robinson. It's sad. Yeah. What's that?
Stupidly.
Yeah, there we go. Right. Well, I'm
recognizing guys who
This and afterwards,
also need that.
then as a kid, like,
What is this basically sort of whatever the one second is a same?
I still give it a shitty ending, and that's why it's on.
And also, yeah.
Because I agree with the data. So, the reason I like to start is because it has things like, I mean, from experience, especially down here, like, after reality, you look up and like, Sopranos is number 2 and number 1, if it's underworks, which way it is, but.
That doesn't make any sense.
Yeah, that's true, yeah.
I was All right. So, friends, let's get back to it, shall we? So, how'd that go? Wonderful, nice. So there was a really cool chart there that I kind of want to highlight because that was fun. Would you mind just posting it on the general channel in Slack? Does anyone else have a data visualization you might want to speak towards? If you do, just can you just drop it in Slack and we'll go in and then you can talk about it. Yeah, in general, please. Why is my phone just blowing the hell up? Jeez. Oh, it's because you guys are talking to me, of course. Cool. So we got Vlad, we got Lucas. Anyone else? Care to share? Let's get one more. Let's get 3. Yeah. All right. Well, hook a brother up. Let's see what. There you go. Word. Arash. Yeah. Wait, Lucas with 2. All right, that's cool.
Well, they're the same data, but one is a split well, one is a split recording.
Fair enough. All right, cool. So let's get started. What the heck is this?
What's interesting, and what's interesting is that, like, because like we broke them down, like with the internet, and what's interesting is that the spike is because of commuters from outside Manhattan.
Yeah, right.
The population of Manhattan increases almost twofold once the workday begins.
I think the daytime population of San Francisco is like 6.5 million and the nighttime.
Wow. So here's a question. So Vlad, right? You and Jackie shared this. Do you consider this a good visualization or a bad one? Okay. Well, amazing. All right. Why?
Well, I think it is I think it's just like really easy to understand, and it's the fact that it's like dynamic.
It's super neat, right?
Yeah, it's
Without
cool to look at.
Without like a lot of words, it just sounds like the purpose of that.
Okay. Yeah. Fair. Those are great points. Yeah.
I was just gonna say that it just depends who's looking at it, because like for us, it's definitely like awesome. It's really informative. But if you're like the head of operational analytics at Uber or something, right? It's like,
Yeah, you don't
shit.
you don't give 2 shits. So
Yeah.
that was like my question too. Is like I saw this and I think like it's really like neat to kind of show a high level or like an out story. But then in my head it's like, well, it kind of raises more questions than it answers. Like I want to say like, okay, well, what parts and by how much? Like you can't really quantify. Like it looks like okay, about 2 times, but like actually how much? Is it 2.1? Is it 2.5? Right? And like so, I feel like this is really neat in terms of like as a way to like hook like a user in or something, or like hey, look at this cool chart. Now read more to find out, right? What's up?
It's a great starting point.
Yeah, it's a great starting data visualization. Also, FYI, I bet you this is where JavaScript. I'm like so sure of it, like 3JS or something. If you guys are interested in doing data viz, I think D3 and or WebGL is the next thing for you to take a look at. Yeah,
That's a little more random question. What's like the main difference between JavaScript
Everything.
Everything. It's a great answer.
They're similar in name only. Like,
Correct.
seriously, they're just, it doesn't make any sense. I don't remember why.
I do.
But you, of course.
Yeah. I do. You mind if
I don't go for it. I don't know the difference.
Okay,
I don't know why.
So here's what happened. A man named Brandon Ike invented JavaScript while working from home from the Netscape Navigator Corporation over a weekend where he drank a lot of coffee. So he called it Mocha Script because he drank a lot of mocha while he built it. They're like, okay, cool, this is a cool thing. They renamed it LiveScript, and they're like, oh, hey, Java's really popular. Why don't we call it JavaScript to ride the coattails of the popularity of Java as a marketing tool. Only with they have like almost nothing in common. I would argue that JavaScript is more similar to Python. So yeah, so there you have it. There is no similarity at all except for the script part, which is meant to like fool people.
So Java's more for web development.
JavaScript is what you want to use if you ever want to do something like this in a web browser, because it's the only language that is allowed to run in the web browser by websites.
Java is for software. So it's used a lot in financial software. And that's if you get a
Stable
job,
long-term software.
yeah, if you get a job doing Java, you're probably writing. So that's a lot of people.
Almost entirely. Although I know Rent the Runway, their like backend stack is in Java, and Twitter switched over because Ruby on Rails kept screwing them up. Hence they fail whale I used to see in the past. Yeah, and like JavaScript is kind of used for everything these days, but like I don't know, like it's definitely not as mature of a language, and it's only been around. It's been around around the same amount of time, but like JavaScript proper, like the stuff that people actually use in production these days, has been around for maybe 10 years with the Node.js Foundation, which I think is about 10, maybe 12. I don't know.
Node.js.
What's up?
Yeah, I said yeah, I think Node.js.
Yeah, like 10, 12-ish or something like that. But anyway, I'm glad that you brought it up. But yeah, so like this kind of database is awesome, but I feel like you do need very specialized software to do it. So we're not going to be able to do any of this. And actually, to be honest, I think it would take me like a week or two to actually come up with a way to make this work, because I feel like that there's a lot of stuff here that like I'd have to look into, especially the active overlays you have in this Angular. Is a lot of like 3D-ish kind of stuff that actually isn't super easy, like regardless of language. All right, this one. So this one was really fun. You guys had a great conversation about it. I think I just interjected and said random bullshit. But like, if you guys could speak towards why you chose it and if you think it's a good visualization or bad.
So I think it's a bad one.
Okay.
So the reason I think it's bad is that if you scroll down a little bit on the verse,
Okay.
it's something like The Wire or The Sopranos, who have things where it's like a 9.2 for the series and a 9.1 for the finale for The Sopranos. And if you scroll down a little bit further, and they're in the worst category, which like is technically true, because their finale on IMDb scored a little bit worse than their overall average did. If you go down to like 24, that is like 8.4 and 9.1. So like both of those are lower than they're as lower than The Sopranos. And like in fact, like the 9.1 is exactly the same as The Sopranos got. So
What's
it's
the
under
point?
the better category. So it's just like it is displaying everything the way that it's supposed to, but it's just not really. I don't think it's well designed.
Right. Yeah. So that makes a lot of. And then I think you sent one that you thought was better, right? Was it this one?
Yeah. So this one shows the same data. So it shows the last episode rating, and it shows the overall series rating. But it also shows how many votes it got on IMDb. So you can kind of see like which data might be skewed because it had a little bit more or a little or a couple fewer votes. And you can also get a better idea for where things should lie based on whichever axis you're looking at. So here you can see that like Breaking Bad and Game of Thrones are both very highly rated for overall, but Game of Thrones is much lower for the last episode rating.
Right. Yeah. I like how this one breaks into quadrants, right? Where you can kind of see like the ones that were like doing like roughly the same, and then ones that were really polarizing. So I guess this isn't polarizing, but like you showed it well, and the episode did well up here. You showed it well with the last episode. Where the hell I met your mother?
Middle.
Wow.
Yeah, I know, right?
Yeah. Alright, well, I guess that makes sense. Anyway, so yeah, I thought what this one was super interesting. I think like even something like this is kind of neat and interesting to do, and you can't really do this with just out of the box. At least not in the stuff that we're gonna learn. But just to point out that like if you have the data, you can like kind of slice and dice it to make it do anything you really want. Arash, it looks like you have a question.
Yeah, I mean, I guess my issue with this is
Maybe it's just hard to see because
it's hard to see. It's kind of hard to read. I guess.
yeah, it could stand to be a little bit like larger, right?
Yeah.
Definitely. Yeah, just make it a bigger font.
Some of the axes were more defined, and then if you actually label some of the quadrants, you understand.
Yeah,
Yeah.
I agree.
Yeah, it really doesn't make any sense that the x-axis is divided in three and the.
That's a good point,
So
right?
it's actually totally edged up, is that right? This is bad because you can't have one axis go from 2 to 10 and the other one from 7 to 10 and no like super duper point to that because I mean everybody will read this.
That's
wrong
cute.
way.
Yeah, that's true.
It's actually quite.
I didn't realize that either. But good point, man. Like, take a look at this. Oof.
I
Yeah.
guess like it will only work if like the chart title is like plotting at least halfway decent shows compared to, you know.
Yeah.
Yeah,
If you
fair.
normalize those numbers to the axes. That's just.
It also says like the 25 most popular game shows. So you assume that all of them are fairly American.
Right. So above 7, but like that's a connection that's hard to make, I think. Right. Like I don't think any of us did it until you pointed out and we realized, oh, cool. All right. So and then Will, you had this one. We're like
Yeah, this one is we thought this one was all bad. It's there's no metrics on the y-axis to indicate what it's actually measuring. I think it's measuring Google Trends, which indexes everything to the highest day, which would be 100, in which case there shouldn't be.
Interesting.
But it doesn't say that, so it sort of makes it seem like it's measuring like the actual sum of your searches. But in which case there's still no like it's not millions.
Right. That's the question I was wondering. Right. Is it like what's the scale here?
Right, but I think it's Google Trends measurement. Right. Right, well, it sort of would be like the day where it searched the most would be 100, because it makes off of that.
Gotcha.
Goes up to 100.
That makes sense.
But that's, you have to kind of intuition.
You don't have a background, really, right? You have to know that in order to be able to pull that up.
And if that is the case, it definitely shouldn't have one of those.
Yeah, right. Yeah, I wonder why like that even. I wonder if that's like a kind of a quirk of like whatever plotting software was used, where it always has to show one above or something. But even so, it does kind of like mess this up a little bit. Although I would say that like, so this is a chart where I think like represented alone makes no sense, but maybe in the context of additional information, it might actually be more useful and maybe even good, right? But that's an interesting point like to raise, right? Is that when you're telling the story, like I guess you can get away with doing something like that. And the question is, well, do you want to make every data visualization stand alone on its own? Like I don't know. Yeah, Arash.
And it also raises the question of who's Googling how to cancellation. Just sort of like without.
Sorry, like who's Googling?
Like, you figured how to cancel video without Googling it?
That's true. Like you probably can.
That's a matter of UX. It's a dark pattern. It's hard to actually cancel things like that because they make it all difficult to find.
Really?
So I'll give you an example. I had a Blink gym membership.
Oh my god.
Okay, people already know. I have to go back there and like tell them, hey, there's no way through their web UI to do it. Like period. They're like, you have to go back and talk to us and explain why. And I'm just like, wow.
Yeah, my credit card expired, so we would have something call me, and then when I picked up, I would have to call them back, and then I'd sit on hold for like half an hour.
So they did the same thing to me. My credit card expired, so I was gonna just like let it be, and then they threatened to take me to collections. And I was like, okay, fine, I gotta like do something. I shouldn't have. I mean, I'm embarrassed to say I took it that far because I thought, oh, it's gonna be done. They'll just be okay with it. They were not okay with
No,
it.
they'll just stop charging them. You know, so.
Yeah.
To go back to the last one, it's almost like it was made in Excel, a lot like very detailed stuff, so it's very good.
Fair. Although, yeah, I guess that's like a qualitative factor too, right? Like, I wonder. I guess it depends on, again, your audience, right? If you're trying to like present a case, you might want to make it look really attractive.
Well, even if my audience is very technical, plus I'm like,
Yeah, that's a fair point.
like, I at least understand how to make it.
Right. Yeah. No, that's a fair point. Whereas these definitely from the design perspective are much better, but probably much more custom. So.
And also, I want to say with this one, there is no good reason whatsoever to color and size for the same thing. It doesn't really add anything.
Right, because
It's
the.
make it better readable and color.
I agree, because the varying differences itself is enough, right?
Yeah, because then you wonder if there are other meaning to the color than to the size of the left parts and the wrong.
Right, and if there was, it would be nice to have like some sort of like key or something, right, to kind of
I
demarcate.
also don't understand why, like, if use a couple shades and then it's made that one is like.
Yeah, fair. Wow. I feel bad for the person who made this. You, Karma, Caribbean, 94. We just like went to town on this poor guy's or person's chart. And here's the last one. So I saw you guys talk about this. I'm like, I don't know what this is doing. Did you figure it out?
Yeah,
Okay.
it's like kind of like a, I mean, we mostly
Oh.
just chose it because it's kind of like a DB pie chart.
Okay.
But yeah, so, the wages are like the totality of how much you, sort of have, I guess.
Okay. Or like make over a pay period, whatever that might be.
Yeah, and then all the sort of like cheese strands are like, how much of the part of the whole that they are.
Gotcha.
It's a much better way to represent what I would have represented data to.
That's a fair point.
Because there's a lot of data points, small numbers. It's, to me, it's directional. You can see the velocity in that. See money, it's going here. It's here. Almost like you're building out cars or something.
So it's also like a dissection.
Yeah.
Shows dependencies as well. Here's all.
That I like. Although, do you guys get what the different colors are supposed to mean? Like, I see this is like these are not really the things you need. I mean, that are you copying something? Like that should be red in that case. But like, I'm just wondering, right? Like, is there like a key for that?
I get the colors I set from green and coffee.
I don't understand why recreation is still great. It's really always me.
Recreation?
Yeah.
$20?
The colors
seems
also-
fair.
A movie ticket, bro. Come on.
So,
3D.
so how they use it in website analytics is that each web page, because this is very common in website, right? You see the path that
Right.
certain web pages are assigned to certain categories, right? Like you go to, I don't know, for T-Mobile, you can see like cell phone plans and cell phones, both are labeled commercial web pages where consumer can actually select something to buy. So like they're just doing this broad category where web pages are like assigned to based on their function. Yeah. And-
Right, which makes sense.
yeah, for most websites, this is a cluster. Like, it's just a mess, because all iterations of web pages have been involved. I could talk about that for hours because it drove me up the wall last year.
Yeah.
Like, it can be a mess, that's the thing, unless you like really simplify it. Like, it takes a lot of cleaning to do.
Gotcha. But yeah, so this was a good one. So do you? I think like, yeah, it definitely has some positive aspects to it, but there's definitely like a bunch that's a little like question marks. All right, cool. So hey, I hope I thought this was kind of fun. It's always just neat to. Oh wait. Nice. Thanks, Evan. You want to talk us through this one?
Yes, so,
We're good. Appreciate it. Here, I will react to that because it's react worthy. All right. So anyway, guys. So the idea was hopefully this was a fun exercise, and what we what we want to do is we want to investigate how we can build at least some portion of these plots on our own, right? Through Python, because what we've done is we've gotten to a point where we learned enough Python that we can, leverage a library like pandas and so forth to perform some rudimentary data cleaning, exploratory analysis, etc. It'd be nice if we could maybe visualize some of our analysis to tell a better or more compelling story. And so that's kind of the main point of talking about this stuff, because based on the analysis that we do on our data sets, like there's a wide variety of different paths we can go for displaying a visual example of that. But the one blocker kind of is actually, or not really a blocker, but like one thing that we kind of want to talk about before we get there is I want to talk about an alternative way to display this. Now, we have learned how to run Python on our own in the terminal, and like on one hand, that's like great because that's like the one correct or like the fundamental correct way to write and run Python code. You do it in the terminal, and if you can do that, then you can choose which environment you want to run it in. So you could, have an application server and run some code in the application server and build yourself an API, or like you can put it up on an IoT device, run your Python script in an IoT device, and now it does something that interacts with the actual world. For the sake of analyzing data, it's nice to be able to really, what are you trying to produce, right? You're trying to produce an argument, trying to produce some sort of analysis that's going to be a lot of text, a lot of exposition, and then like maybe a couple of charts, maybe a couple of data visualizations and so forth. So in order to achieve this, there are a couple of tools that are available that we can use. They're namely called notebooks, effectively. So the popular one these days is Jupyter notebooks. And what a Jupyter notebook is basically it's a glorified website. It's a special website where you can sort of tell stories. So you can write words, actual human words and stuff, and then you can also put in Python code, blocks of Python code that will run and embed the output right here for you. So what you end up with is just a story that you can read from top to bottom, which can be a story of analyzing OMDB, movie rating, or all the other stuff that we're kind of talking about. That's the way it works. Now, the way Jupyter notebooks work is kind of in the same manner as we talked about, where you can pip install it in your terminal, and then you can open it up in your computer environment, which means that it will start a website or a web server, as it's called, but in your computer only. And what you do is you write this, it's interactive, and it will produce a file that it doesn't look like code, but it's like codey. It's it's called JSON actually, JavaScript object notation, effectively. And that JSON can be parsed and rendered by a whole bunch of other programs. That's kind of the way it works. So instead of us opening up a .py file and running a bunch of code, what you do is you open up this kind of interactive approach where you actually use this as you would a text editor or a word processor. What it does is it produces these file outputs, and their file extension is not .py, it's .ipynb, which is IPython notebook. And these files are special because they basically take all of that and convert it into a specific format that you can basically upload or do anything you want with, and other programs can read them and redraw them. That's basically the way it works. What we're going to do is we're going to use, so I was doing a bunch of research into how we can make this most useful for everyone, and I stumbled across something really fucking awesome. It's called Colab. So Google has this really awesome project where you can actually create these IPython notebooks or Jupyter notebooks on Google, and you can save it and you can run it on Google's computers. So what that means is you don't even have to have Python involved or installed on your machine. It just works through here. So I thought this was really interesting because what this means is not only can you create these, you can publish them, you can share them, etc., etc. You have people work through them. So I thought I'd take some time today for us to kind of just explore this tool And then also, if we could go over the homework 5, through this, just to kind of show you how that piece would work, then we'd be at a place where on Thursday we can start to use this to embed graphics as well, because then it becomes really interesting, right? You can say, I am going to analyze OMDB. And if we clean this stuff up and count the number of unique genres, this is a chart that displays what we have, etc. Right? So that's kind of what we're trying to get towards. And it's important because for your final project, what you're going to submit is an IPython notebook. But the other thing that's really neat about it is they have a really tight integration with GitHub. So you can take any of these and you can save a copy of it in GitHub itself. And GitHub will actually pre-render it for you. So check this out. So if you take a look at something like this, for instance. So in GitHub, a .ipynb file is automatically pre-rendered for you in this manner. And so what you can do is, like, you can share this with anyone. So you can say, hey, here's my analysis. Here's a link. It's online and public to everyone. So I think that's a really cool like workflow and a cool way like for you to be able to do a bunch of this analysis and so forth. And so that's kind of the workflow that I want to kind of walk us through and ensure that we can be able to really understand it and use it to do a lot more data analysis. So the way it's going to work is effectively, like, you can go to Colab, and the way this works is if you click this, it'll take this and open it up for you in Colab, so you can start to like change it. So if anyone else wants to take your analysis and do more stuff to it, it's kind of easy and available. But we're gonna go to Colab and we're gonna create some sample stuff, some sample notebooks. Then we're going to push it to GitHub through their GitHub integration. And what that's going to do is that will give us a web URL, which we can then, it's like effectively a deploy, right? So your web URL is published, and now you can share that there. That's the game plan. So let's begin. I want everyone to please go to Colab for me, and just, I think you might have to press a couple of buttons to kind of, get going, but I want you guys to create a new Python 3 notebook. So I'm gonna send you the URL. And what you're gonna do is you are going to please create a new Python 3 notebook. And then we'll do it as a class, right? And run like, so just do like file, new Python 3 notebook, give it a name, OMDB analysis. Then here, if you want, you can say like print, hello world. Right, so this is what you want. You want to be able to do this and get this guy. That's your objective. Go for it. Does everyone have this? Cool. So, permission to move on then. Yeah, solid. Okay, cool. I am, guys, like, I'm so excited about this. I was like, man, I wish I had known about this like a while back, because this just simplifies everything, right? And so there's a couple things that you can do here, right? So the whole purpose or the way a Jupyter Notebook works basically is this. You have the ability to either create a code block or a text block. So if you create a text block, it's going to give you this like rich text editor. However, it does use Markdown. Has anyone ever heard of Markdown? Okay, good man. I mean, yeah, obviously. Markdown is the truth, guys. It is the best way to write rich text editing. Has anyone ever used a what you see is what you get editor, like on WordPress? You have, right? Yeah. Yeah, that shit is lame. I've actually built some on my own back in the day when I was doing a lot more like front end dev, and it's like the worst thing ever. But what's really neat about Markdown is it's like a sub language, right? It's like a shortcut language that will transform into predefined format. So for example, if I wanted to have a giant page title, like okay, like OMDB analysis, something like that. What it does is it will go ahead and render an H1 block for you. In the same manner, if I wanted to do a H2, what I could do is I could go do something like this, and I can say, okay, some subheader. So the idea is, you could use these as a way to kind of give you some sort of hint. So to italicize, you just have to put two asterisks right next to each other, and Markdown knows to draw it in that manner. Is that fair? Make sense? So I want you guys to explore this just a bit. So what I want you to do is I want you guys to go ahead and do me a favor and do this. Add some content that embeds a GIF image and a link to OMDB website. Okay? So you have to explore Markdown to kind of pull this off, but I want you guys to do it because being comfortable with Markdown is one of the key aspects of being able to work properly with the user. Let's take like 3 minutes to do that. Find a good GIF. Solid, killing it, fam. So the idea is this, right? I think generally, like honestly, if I were you guys, I would put Markdown on your resumes once you like get to a point where you're comfortable with it, because it's like a really cool tool. And I know me, I get really excited when other people like know it. So if we wanted to just add some, if you wanted to embed an image, the way you would do it is this. Here is some alt text for image. And then you just go ahead and find one. So let's go to Jiffy, and let's get a picture of a kitten. Oh my God, that's the best one. The one thing to keep in mind is when you embed stuff, you have to do the .gif image, but both, right? So the idea is you have a lot of flexibility here to add content in a bunch of ways. I think they also just let you do this. Like you can just hit this button. Yeah, see that's when you hit this button, it'll tell you alt text, and then you put the image URL, and it'll just like make it show up. Worst case, what you can do is you can just be like, oh, hello, this is some markdown text that does stuff. right? And you kind of get something that looks like this. Now the beauty of it is, if you click out of it, or if you add like a code or something, what the notebook will do is it'll show you the rendered version, right? So what you're doing is you're basically creating a blog post, except the blog post has the ability to run Python code. Fair? Any questions so far? Yeah. Please.
How do you make the picture of the link?
How do you make the picture what?
You do a link.
Oh, good question. So the question is, how do you make the picture into a link? So what you can do is this: highlight the whole thing and click on this guy. And do you see what it does? It actually, oh, this is stupid. It doesn't do that. So let me show you something real quick then. So I'm going to put it here just so you can kind of see it, right? So to display an image, you do this. You say alt text and then image URL, right? To add a link, you do link text, link URL, yeah? To do both, to make an image a link, you do this. Link URL, and then inside of here, wait for it, you do image alt text, image URL. So it's ugly, but it'll work. Does that make sense? You kind of combine both of them, this and this, together. So gross, but you know, it is what it is. Bless you. So that's basically, you know, where that takes you. What's really nice about Colab, bless you, is that it also creates a table of contents for you. So like if I were to add more to it, actually I'll show you in here if I do it here, like for my conditionals, right? If I open this up in Colab, and I do this, it'll actually show me like each piece, so I can kind of like walk through it. And if you want, you can kind of minimize them too. And by doing so, you end up kind of having a more condensed. Like you can say, okay, here's a subsection, here's some code on it, so you can say analysis of this stuff. So you have a lot of ability to break up what you're trying to, the data story that you're trying to tell, using these formatting options, right? And again, the whole thing just runs on Google. So if you do expensive computation, I think they have like some understanding of what that means. Like if you look here, like there is some predefined like RAM and disk space that you are able to use. But again, like I think you get 12 gigs of RAM. I mean, like I can't think of any data task that you guys might want to do that would take that much. But so that's kind of neat, right? So if we were to go on, like I think you know, as far as the Python piece goes, the other thing that's really nice is you don't have to do the like requirements.txt stuff. You can just say, okay, import pandas as PD, and you can say, and like basically like that's it. It just works. So now if you want, like you can do something like what's up?
Will only work for that cell.
Good question. So Arash is wondering, is it only going to work like for that cell? No, it gets added. So all the cells in combination is like one Python file,
Okay.
right? So what that means is the scope is maintained. So if I do something like this, if I do like, okay, a equals to 1, and then I add another text box, well, what's a though, right? And then I add another code block and I do print a, it will give me 1. Oh, I have to run this first though. That's important. So I run this, and then I run this, and it should give me 1. You see that? So the idea is that the execution order does matter, but if I declare something in this code block, I have access to it in this code block and all subsequent code blocks. So you can build on stuff. Any questions on that so far? Okay, what I think would be useful is if we took our OMDB homework and we built it, but as a class, right? So as a way to go over the homework as well. I mean, for the most part, it was pretty straightforward, right? There's like 1 or 2 questions that was like a little bit out of left field. And sorry, 13 and 14 were the same question. I think I meant up and down or something. Sorry about that. But I think that's what we should do, yeah? And I think that'll help us kind of understand how this piece works. So I'm gonna delete the cell and delete this cell. Delete this cell, all right? And let's get started. So we can start off with, okay, OMDB exploratory analysis. Right? So in this notebook, we will explore a few key. What's up?
That's the people who rather add it.
Correct. All right. So actually, worth bringing that up. Thanks for. Oh crap! I'm doing it in my work. Damn it! All right. Come on, fam. Don't do me like this. Really? All right. I just realized I can't be doing this with work stuff. Who cares? But then I'm gonna say file. Can I just delete this thing? Yeah. No trash. Go away. Here. Oops. So here's an interesting question, right? So if we were to take a look at here, right? Here's our OMDB set of data, right? Like whatever. Let's save it. OMDB rated. It'll go to downloads. Replace Shoreman, whatever. So how do we get this on here, right? Like what can we do? So if you go here, you actually have the ability to upload files, right? So if I hit save, you see how there's sample data? What I can do is I can just upload any kind of file that I want into here, including my movie rated.csv. The one problem with Colab is that it does go away when the runtime is killed. So basically, when you start to run this code, it'll create a runtime, and that'll run for the duration of the notebook. When it's gone, this will get cleared. So that could be problematic because that means that you might have to re-upload it, or whoever is playing with it might have to re-upload it. You can get around that, but there aren't any really good things that you can do there. What you can do is you can actually connect directly to Google Drive and pull it from your drive. So if you have the data in your drive, you can pull it in. Yeah, Jackie. Oh, I just went to, so if you click on this dude here, right, oh, because it's, sorry. It won't move, but it's right there, that guy. If you click on that, it'll actually give you this tray. And in the tray, you have a table of contents, your code snippets, which are just like cool shit you can do, like, wow, camera capture. I haven't played with that, but that should be fun. And then files. So in the files, you can do, whatever you need. And so the idea is that is how you get it into Colab's sort of file system. So you can pull it, read it, do pandas on it. Questions? Okay. I know. So hey, can I ask everyone to please just upload their OMDB guide up to this so we can. I think it'd be good if we work to this together. Holy shit. Wow, okay. Okay. You guys need a few more minutes to get this going, or okay to move on? Good. You guys?
Which folder was that? Actually, the dots.
Sorry, for which one? I just went to file, so top
Yeah,
level.
no, I actually like the dots.
Oh, you went into dots?
Yeah.
Oh, fun. I don't know. Maybe content? Yep, content. No problem. That's fun. Once you go there, you can't go back in.
Yeah, it's kind of annoying.
Yeah. But you should still be able to upload it. All right, cool. So now here's what I want to do. I want to go ahead and explore how we can actually pull those in, right? So if you do this, it'll actually show you what files you have. So you know how in terminal, if you do ls, it'll show you all the files you have. This will show you like what your current directory is, which is useful because you can use this now to connect. Does that make sense? So if you want, like you can just keep this, right? You can say something like, okay, oopsies. Like you can say, first find out where we are. And then if you want, you can say, okay, import pandas as PD. And you can say omdb df equals to pd dot from csv movies rated. Does that make sense? And then if you want to see what it does, print omdb df dot head. Sec. Oh, sorry, read CSV. This is what you should expect to see. Sorry, let me decrease this.
I think I dropped my movies rated to movies. See that?
So, right, so I think, so, yeah, so you know how to write it, you might want to do dot dot slash slash dot dot slash movies rated, and that should pull it bigger. You see what I'm saying? Yeah, except like you gotta do that with the green CSV. So the whole point of the LS is to see where folder you're in, right? So I think the other thing you could probably do right? So now you can upload it, right? And now you should be able to. Yeah, but you can't be python, right? CSV. So you just do a refresh, right? And then you go to your file, and upload, and find where your CSV file. Right? Now there's Excel, where's your CSV? I don't have it. You just save it. But okay, it's coming. Yeah. So now if you copy what I have, it'll work. So then,
That's read.
yeah, it's pretty intuitive, right?
So do the do acceleration. Oh, well,
No, that's one.
so it needs to be
Like,
Oh yeah, yeah. Once you have it done, right?
You can upload it to notebooks, but
That's all it is, right? Oh, here. Sorry.
Yeah, I think it's true.
it doesn't work.
Yeah, you can put your Python file straight up there, but there are like tools that you can convert a Python file into this. In fact, I used one last night to convert all of our class notes into this. Right, you can write scripts to do it. You use something called NB convert, and then from there you can basically read any file you want and then like push it in.
But you can't just upload the
So you
image.
have to upload
Yeah, you can, but you can upload a .ipynb file though. You can upload notebooks.
Yeah.
Yeah.
That makes sense.
Cool. All right. Okay. Move on, guys. What's up? Who's asking? Cool. All right. Okay. Move on then. All right. I think that's the only tricky slash annoying part. Once you have your data, you're good. And just remember, I believe with pandas, at least the latest version, you could drop a URL and it should be able to just pull that in. So that could be a shortcut if you want to. I'm pretty sure read CSV not support web URL. So it'll just do the request.
That's actually useful for me.
Nice. I thought I read that like recently. I could be wrong, but I'm pretty sure. Meanwhile, back at the ranch. So this is what we got, right? We have our data. We are displaying the head of the data. So why don't we move on and see how we can proceed with this guy, right? So the first step is to import the CSV as a data frame. So like if we were to write this story, our first step is to import the CSV, right? The CSV data set. CSV file and convert it into a data frame object for processing. So the idea is like here you actually write what the hell you're doing and exactly why you are doing it. And then you can even say something like this, where like you can say a copy of this data set is available here on GitHub, right? As you can see, new lines are kind of like not really respected here. So one thing you could do is if you really want, like you can do this, and then you can add text, and then you're good, right? And so forth. So then our next step was, okay, print out the first 5 rows, right? So we kind of have that here as the head, but what we could do is we can create a new and say, okay, observing the first 5 rows. And then you can add code, right? And you can say, okay, first 5 equals db.head. The one thing to note is if you just do this, if you don't store into a variable and you just run a command, it will take the last command and it will kind of build it out for you. So you have that ability. And then if you want, like you can also use print and so forth. You have like multi-step problems. But yeah, boom, that's it. That solves that part. So then we can kind of like go on and keep moving. So the next step would be, all right, print out the num rows and columns in the data set, right? So in this case, we can say, all right, go away. Oops. You can say omdb df dot shape. There we go. Done, right? And then so on. And so like the idea is that if you do it this way, and again, you kind of have this like neat little each piece. Which you can also kind of pull in here per problem, if you will, right?
So are you making them each into a section?
Effectively. So every text block is its own section.
Okay.
Every code block is its own section, and you're able to toggle text blocks. And when you do so, all the stuff inside of it are also toggled. The other thing is, if you want to move a row or a cell, you can do that by pressing these buttons, which will take a cell and move it up or down. So if you wanted to traverse, there's no drag drop functionality. So it's kind of lame, but it is what it is. If you want to insert in between, like you can go here, select this, and then if you hit text, it'll add it in between these two. And you can delete in this manner. Excuse me, thank you. All right, so next up, right? Having done this, what we want to do next is we want to print out the column names. All right, how do we do that? Okay. You want to do omdb-df.column, so right? So right, you turn it into a list, right? So yeah, like I mean, this in and of itself is fine, right? You could just do that and you're good, right? Here's a list of all the columns. If you want to turn it into a list, you could. You could probably even like run a for loop through it and say for each item in the column list, display the item, etc. Right? But the idea is that it's all the stuff that we've been doing, but now instead of having to run it through terminal, kind of here and entirely readable, right? So, and as you can see, you know, here it is. Oh, you know what? I think the way the sectioning works, Arash, is like, see, you see here, this is 2 pounds versus here, which is 1. So 1 is the H1, 2 is H2, and so forth. So everything inside of H2 will be collapsed. Everything inside of H3 can be collapsed, and so forth.
Oh, yeah.
Yeah. So moving on. Yeah. We want to print out the column data types, right? So we can say, all right, well, let's do that next. Highlight this guy, or really this guy, and then text, column data types, code, omdb df dot what? Remember how to print out the data types? It's D type, you're right. Boom. That gives us a series object, right? Which contains the column and its type. Fair? So all stuff we kind of knew about. How many unique genres are available in the data set? How would we do that? Kill and then so we're gonna say omdb df capital M, or let's find out. Sorry? Yeah. Question, does NUnique contain null? Awesome. And there you go, done, right? You also do dot unique and then like dot length or something, or like length of it or whatever. Okay, cool. So now we're cooking. How many movies are available per genre? So, any idea how we could do that one?
The same things that bother these value counts.
Yeah,
You
listen.
create a subset as well.
Okay, so here's two approaches, right? Let's try them both. We'll do the value count, and then I want you to walk me through the subset. Okay, cool. So yeah, for the way that we've talked about at least is just genre dot value counts. Okay, now let's try the other approach. Floor is yours, Alyssa.
Create a subset, genre, group by genre.
You want to do this, right? Genre, title, group by
By genre.
count, right? Cool. I'd probably fuck something up here.
So
But
there's no underscore.
thank you, and probably
And there's no
yeah.
bracket.
Yep. There we go. Sweet. And so, what's the difference between this and this? And how can we find out? It's interesting.
They're different things.
They are, right? The first one is going to be a series, whereas this is going to be a data frame. Correct. Cool. And as you can see, they both give us the same set of solutions, although it looks like this one is also in sorted order. Just neat. Cool. Let's keep going. All right. How many people got this one? All right. Wait, sorry. Oh, right. But now, see what it does. Yeah, now it's zone section. It's because I think it was because I had it as this. Yeah. Right now it makes its own top level, right? I probably had something else slightly different there. Okay, cool. And so the idea here is this, right? Sorry, just gotta look at it. Okay. All right. How can we do this?
You gotta use the Boolean filtering for content rating.
Correct. So let me just delete this. Let me create code. So we're going to say OMDB df and then what?
Bracket, OMDB, bracket. And content rating equals
Take a look at what the content rate. Thank you. Equals R.
Yeah.
And then dot.
Sort values. This is 5.
Yeah, that's probably the one we want, right? I mean, we could also do it by Rotten Tomatoes or a Metacritic, right? But or by gross, right? Yeah, fair enough. So it's a little open-ended, right? It'd be interesting to see how different they are, and then
sending equals false.
5 is by default, yeah. And boom. This is what it gives us, right? Because it's saying top 5 rated. So yeah, done, right? Nice. We could probably try to clean it up a little bit by doing something like this. Doesn't really make that much of a difference. Oh, actually, it does because it wants less lane. So we can just say, all right, all are equal to this, and then we can say all are. At this point, it doesn't really make a difference, I suppose. But either way, boom, there you have it, right? And that's that. Now, moving forward, what is the average Rotten Tomatoes score for all available films? How do we do that? Go ahead, Raj.
Do movies, Rocket, Rotten Tomatoes.
Yep.
There's space in the Rotten
Yeah, it's a pain in the butt. We'll probably change that and like normalize that. But, I mean, and so forth. Anyway, so is this making sense? Are you guys following along? Do you have this so far? Yeah? Okay, cool. Again, the beauty of it is this, right? You kind of have all of these guys written like this. Cool. All right, so the next step is this. We have a few more of these to go through, right? Same question as before, but for the top 5 films, 5 number summary, etc., etc. So let's run through these. And then, actually, you know what? No, I mean, I know like you guys already have the answers for these, but I think it would be good for you to just do them super quick, just to kind of get a feel for how this piece works. Before I do that, I want to show you one more piece, which is how can you take what you have so far and push it into GitHub, right? Does everyone here have a GitHub account or not? What's up?
Oh, no.
Oh, you do. You have a GitHub. Cool. We should follow each other. We don't.
Yeah, I mean, I have contributed to it.
Right, that's true. You have. But let's create a GitHub account because I think the real cool part of this is that now that we have, I mean, it's not completed yet, right? Now that we have this, we can actually push it into GitHub through this tool, and now you have a rendered version on GitHub. I think it's complete. So, can everyone take a couple of minutes to create a GitHub account right now? Is that fair? All right, go for it. Because who doesn't have a GitHub account actually?
Doesn't.
Who does not? Okay, and okay, you don't either, Raj. Okay, in that case, why don't you watch now, and then we can kind of like go from there. So basically, and can you pull from? Okay, cool. So basically, if you go here and you say save a copy in GitHub, what that'll do is if you guys click it, it's going to ask you to provide permissions in GitHub itself. So if you guys can do that, save in GitHub, yeah, and it's going to open that up. So that's okay. Why don't you just go ahead and do file, save it. And you gotta like log in and do your thing, right? Cool. Okay, you guys have all your stuff. Here. You guys do that?
File.
That's gonna ask you to do. Okay, cool. So everyone has that, right? All right. Yeah, I know you got 1 minute. I'm just trying to find a way to get you some time off. So once you let me just do this real quick. GitHub.com. I'm gonna create a quick GitHub repository. New repository. I'm gonna say OMDB analysis. Analysis of OMDB dataset, right? Like whatever. I'm gonna just create the repository. I'm done. So the idea is this, right? So once you have a GitHub repository, what you can do is this. Let me just cancel, open it up again. It pulls in all of your GitHub repos, and if you're me, you have like quite literally over 400, so it takes a little while. So I called it OMDB, MNOP. There you go, right? So you just kind of do that, and it creates this file path. And if you hit OK, what it's going to do is it'll actually take this and create a copy for you in GitHub. The beauty of it is once it's in GitHub, you can, it'll show up here, but it'll also have a neat little, just reload if this fails. It'll have a neat little button that says open it in Colab. And as you can see, all the commands we ran, the output is also displayed. So again, like this is a readable, shareable thing that you can link to anyone. And they can go into it. In fact, my ask for you guys, I'm gonna share this with you guys. I want you to open my version in Colab, and for the sake of just practicing, I want you guys to complete the last 4 or 3 really. It shouldn't take that long. It's more as a way of just being able to see how what you have in terminal plays into Colab itself. So I'm gonna do that right now. I'm gonna share this with you guys at channel. Take my IPYNB, open in Colab, and complete the remaining few problems. If you can, add some color description in Markdown to add more info around what analysis. All right, I want to give you guys 5 minutes, and then we'll go over it, and then I'd like to talk about final projects. Cool, so let's come back at 8. We'll reconvene at 8:19. Is everyone clear as to what the ask is? Just that flow, basically. And if you want, if you could push like whatever, grab mine, make a change, push it to GitHub. Mine, how are we supposed to see? Wait, sorry. No. So the idea is if you go to my GitHub and click on it, it'll be my Python folder. I want you to open it in Colab, save it in Colab, and then make sure you change like the problem, and then save it to your own GitHub.
Oh, this is supposed to be. This. You have to resave the actual system. Maybe, so like I just went to save. Right. Right, because you have to re-upload the file. Right. That's what I said. That's me straight. Here you are. basically.
Awesome. Of course. So it's been about 6 minutes, so let's kind of just like rehash this. The main point here was to kind of show you guys that process of how you can take something from here, push it out as a GitHub artifact as a way to publish it. Then you can pull it back in, make a change, and publish it again. And so I think that like just to kind of walk you through that process, I published this guy here. If I click on it, I can open it back up in Colab and make a change. Should I choose to, like, for example, the next problem is, right, so if we were to do that one, right, so did I open it from, hold on, not this, actually I'll keep that open. So this is probably it, yep. So what I can do is I can say, all right, go away, go away, go away. Column data types, number of unique genres, movies per genre, top 5 rated. And so here, really, it just wants this, the average Rotten Tomato score. So this is lame sauce, right? Because it's basically average Rotten Tomato score for the top 5 films. Is that what it, right? Top 5. Okay. And so what that means is basically we want to probably sort by like gross and then find the mean of the Rotten Tomato scores from that perspective. Does that make sense to everyone? And so hey, since since you're speaking, why don't you give us a hand?
So like the one thing I'd like to do is sorting it.
Okay.
Right? But because I did OMDB Rotten Tomatoes head, right?
And so you just
Top mean.
so you just got the first 5.
I got the first 5, yeah. Because at first I was like top 5 films on the list, and I was wait a second, that's kind of wrong. You know, it should be top 5 films. So now I need to sort it.
You can say what here? Right? Sort values?
Yeah.
Okay. And then what? Well, actually, can you do this? You probably want to do this guy's. What's up? Well, so it's an open question, right? So like we could do it by ratings, we could do it by growth, right? We could also, I mean, to be fair, this is my bad. It's a little bit ambiguous, right? But the question is, what does top 5 films mean? Rotten Tomatoes. Yeah, that's what I think too, actually. So we can say this, right? Head mean. Should be that, right?
Yeah, that's what
Something to that effect. Uh-oh, this is gonna break stuff probably.
Also, you can IMDb too.
Thank you. But it'll still break because, even beyond this thing, it'll still break because now, because I did pull it from GitHub, I have to run through all of them. That's the one drawback. And a part of that means in the files, as you can see, I have to re-upload. So I'll just do that, for our edification for the time being. But that is kind of the pain in the butt where we have to like run this. All right, come on, buddy, run. And then we have to run. I mean, I guess we don't have to run each one of these guys.
you only actually run the one that has the variable.
Correct. And then after that, we're here. And then something like this, right? Except what we have to do here is we probably want to grab Rotten Tomatoes only. There you go. Something like that. I mean, this gets it to us as a data frame. There's probably a way to grab it as a series and do it. Like, in fact, you could probably do df Rotten Tomatoes and then that sort value, that mean. Probably do it for you, dot head dot mean. But either way, as you can see, this tells us that, does this make sense?
No.
It does not. Let's take a look at this. What do we do here?
Sort value is the same as goals.
Correct. Okay, run this. Boom, and now we expect the mean to be just 10. That makes more sense. But now we know that the lowest 5 has an average rating of 7.1, which is actually fairly high. So that says something about this set of data. But anyway, I wanted you guys to, I want to show you guys that process. And then the final thing is, so we made a change, right? If you go and you save a copy back in GitHub, what you can do is you can push it back to that same GitHub repository. And that was the main point I'm trying to make here, the workflow around Jupyter. And the reason why I bring this up is because for your final project, you have to use Jupyter Notebook. The question is, well, how do you like manage it, right? And I think that this is the approach. So now we're back here, and if you hit like OK again, what you'll see is prior versus now, like, did it work? Yeah, right here. Now we should see the same thing, but now with an additional line item, which is that guy. Check. No, your own. So like when you connect, it'll be to your GitHub account. You have to create a GitHub repository. Oh, that's so weird. Good luck. I didn't. That sounds that clever. That's so fucking weird.
It's kind of.
You know, that's really interesting. I'm sure GitHub will prevent you from doing that, maybe.
It's probably gonna, probably try to do.
Yeah, try to do it on this one, OMDB analysis. I think you discovered a security vulnerability in Google. You should submit that and get $5,000. But like, that's really unexpected because, sorry, my expectation here was that it would open up to your GitHub and then you guys could kind of pull it in. So that's really interesting. Actually, Jack, could you try it? Could you go to the OMDB analysis?
Yeah, I can't see it.
What's up?
I can't see it.
You can't save it.
No.
Okay, good. So at least it doesn't let you do that. That's really super interesting.
But if their account had.
Then they would be able to. Yeah. Well, I feel like what you could do is, I think what you're supposed to do is once you pull it in, you have to save a copy into your drive, and then it'll connect to your GitHub. But either way, I think that I still wanted to highlight this flow because I think that, well, for sure, when we do Matplotlib on Thursday, it's going to be basically, hey, here's a notebook. Why don't you open it up and then work through it? So I'm going to use this as a way to distribute this information to you guys. And then when you guys have your project ready, I want you to submit it to me in this manner where you have a GitHub like repo, and then in the repo, ideally, you know, there's like a link to this notebook, and then this is your final project basically. And when you present, you're gonna walk through this basically and talk us through something. I wanted to actually go through that today, but it looks like we don't have time, so we'll start off on Thursday, first talking about how the parameters of the final project. I'm gonna ask that you propose something by next Tuesday, and then it gives you a week to work on it, which I think is like fair. And we'll finish up the last thing we have, which is Matplotlib on Thursday, and probably I hope to finish like early, so that like we can spend like maybe the last 30 minutes or 45 minutes. Like I can sit with each of you guys and we can kind of talk about what you're thinking and what your game plan is, right? Arash, you had a question?
You can only actually call it to the public.
Correct. You cannot do anything to private. Yeah, which I think is by design. We can't really do much there. But then, the other thing you should know is that if you did want to, if you want, you can also just go File, and you can save this. You can download this notebook, the IPYNB notebook, and then you can upload it anywhere you want, including a private GitHub repository or anywhere else. This is the kind of a nice shortcut, but you don't have to use that. Cool. All right, if you guys can fill out the extra before you go. If you have any questions, please let me know. And otherwise, I'll see you Thursday. That's it. Thanks, guys.
Thank you very much.
Thank Thank you.
How do we get the URL? Your own analysis.
Oh, you want this guy?
Yeah.
Here. Why don't you give me your email? I'll send it to you right now.
BICTOR.
Sure, let me go to Gmail. Actually, let's do LinkedIn. Let's do LinkedIn.
Ethan Victor Feintuch. FEINTUCH.
No.
No.
VIN.
VIC. Victor.
And then
VICT. No, you have a K there. FEINTUCH.
which one?
Yeah.
That's you. I'm going to message you. Oh my God, LinkedIn, you're killing me. There you go. Here it is. Add a note. Done.
Great. Thank you.
Thank you. Have a good
Very
one.
good. Thanks.
Of course.
So, I'm in between jobs now.
What?
The first suggestion there is the guy from the fire.
Oh yeah, Firefest Billy, that is hilarious. That is so fun.
That's amazing.
He's my friend.
Yeah, sure, yes, he is.